In this tutorial, we're going to learn how to set up cloth simulation in Houdini, and how to create constraints, and how to attach geometry parts to cloth using deformers. So let's get started. First of all, let me run through the current scene setup as the starting point for our cloth simulation. I have 2 lights and 1 camera in the scene. I also have a geometry node called Remy to contain all the components of the geometry parts. Let's take a look at what we have in the Remy geometry node. I downloaded this character from mixamo.com. I imported the film box into Houdini and have made some changes so that we have a full body as the cloth glider. I downloaded one walking animation as well and made the animation cycle. And in the Remy rigging geometry node, I rigged the body and finally I have a geometry node called Remy cloth simulation for the FX. I did the object merge in the top and bottom cloth. And also there is a top network which is empty at this moment. So let's start to create some cloth simulation for Remy. Let me dive into the .NET. And drop down a cloth object node for top and one more for bottom. Then name them top and bottom. Then merge them together. Then I need to create a collider for the cloth and static solver. Drop down a cloth solver for the cloth objects. Then add the gravity force. And the network is set up. And now let me point the cloth object to the actual geometry. And let me change the start frame to be -6. Oh, by the way, the animation start from frame 0 and the T-pose is at -6 frame. And I can see the top is cloth object is here, but I don't see the bottom cloth object, and also I don't see the body. So let me point the static object to the body geometry. But again, let me first object merge in the body first. And I need to merge in the body geometry from Remy rigging geometry node. And the good practice, of course, is to create a null to indicate the output of the rigged skin. Now let me go back to the FX geometry node to object merge the body again. So let me point body to the out skinning we just created. Then let me dive into the .NET and point the static object collider to the object merge node we just created for the body. Let me run the simulation, and yes, the top shirt is colliding with the body, but the body is not moving, and I still don't see the bottom cloth. First, let me turn on use deforming geometry for the body to make the body animate. Let me run the simulation again, and the body is deforming. The cloth is colliding with the body. Then let me fix the bottom cloth issue. It's pointing to itself is wrong. It should point to the other bottom object merge node. Okay, now we can see the pants eventually. Okay, run the simulation again. Everything should work just fine. Next, let's create a constraint to constrain the bottom cloth, the pants, to the body, so it won't fall. Let me drop down a cloth attach constraint node. This node need to know what is the constraint object and what is the goal object, and what are the points on the constraint object that being constrained to the goal object, and also the primitives on the goal object that the constraint object being constrained to. Go up one level, make some changes to the top and bottom geometry to indicate where are the points and where are the primitives. Let me focus on the bottom cloth object first. Double click on the top border and convert the selection to points. And in the viewport, drop down a group node and name the group to be bottom constraint points. And make sure the group type is points. And again, a good practice is to drop down a null node to indicate that's the output for the bottom geometry. now let's move on to the body, display the body, and we need to know where the points will be constrained to. So turn on the template of the bottom cloth, and I need to select the face loop, and in the viewport drop down a group node and rename the group as body prim, and make sure that the group type is primitive, and again drop down a null node to indicate that's the output for the body. Okay, let's step back into the .NET, and since we have made some changes to the bottom and body, let's point it to the out bottom we just created, and select the body collider and point it to the out body, and now let's select the body attached constraint node, and in the field we need to fill in the constraint object and go object. So for the constraint object, from the drop down menu I select the bottom, and the constraint points is the group name we just created. It should be bottom constraint points, and the goal object will be our body collider, and the goal primitives is the primitive group named body prim. So after everything is filled in, let's hide the top and see the constraint. You can see the constraint guide there, so it's working. Unhide the top, and let's run the simulation again from frame -6. You can see that there are some areas that have issues. This can be resolved firstly by increasing the substeps of the clock solver. And so let me select the clock solver, and the default substeps is 4. I increased to 6 and run the simulation again to see if they make everything better or not. Okay, better than before, yes. Okay, let me run a flip book of roughly 120 frames, and I will get back when this is done. By the way, this is a quick tutorial, so I won't go into details of tweaking clock settings. And let me show the final result of this flipbook. Next, let me attach the flaps onto the bottom cloth. First, let me select the output node and click the Save to Disk button to save the clock simulation to the disk, so that later we can bring it back. When finished, we go up one level. I select the .NET and turn on the playback simulation, and the path should be the cached clock simulation sequence file. Okay, it's time to object merge in the flap. So drop down an object merge node, name it flap, and point it to the out flap in the Remy model geometry node. And as usual, drop down a null node, name it out flap. Now we need to ret out the geometry cache for the cloth simulation. So let me grab the .NET and hook up route output driver. Not render, but route output driver. Okay, let's change the frame range to our cache frame range 120 from -6 to 120. And okay, we're going to generate into $heap geometry geo folder. So okay, hit the save to disk button. It will take a while to save out the geometry cache. Then now it's time to bring back the geometry cache and use it to deform our flap geometry. So drop down a file node, okay, and browse to heap $heap geo and select the cloth simulation geometry cache. Okay, display that. Okay, the simulation is back, and name it cloth geocache. And we need to use two nodes. One is cloth capture, the other one is cloth deform. We use these two nodes to drive the flap using our cloth geometry cache. So first of all, connect the flap geometry to the first input of cloth capture and the cloth to the second input to capture the flap geometry. Then secondly, connect the output to the first input of cloth deform. But before doing that, let's take a look at the capture, and the radius is too big. We need to tweak it. For example, 0.1. To see the range of the capture. Yeah. And because we only need to use the T-pose cloth to capture the flap geometry, so we need to freeze it. So drop down a type shift node and delete the frame expression, leave it as -6, and connect the captured flap geometry to the first input of the cloth deform node, and the time shift cloth to the second one, and the cloth itself to the third one. Now let's merge the deformed flap geometry with the cloth geometry cache, and we have everything together. Okay, this is all done. Okay, looks cool. Oh, just another note. When we catch the simulation and write out the closed geometry cache, we should just write out the clause itself. We shouldn't include the body geometry. So that's something we shouldn't do. But anyway, you can do it yourself. Okay, that's all. Hope you like it and see you next tutorial.